meta classes. And I don't know, I don't have any expectation of formality, so if you want to interrupt or whatever, think I'm going too slow or too fast, just you can. But yeah, so I guess we'll just dive right in. So first we kind of have to start out with just a silly example, because that's what, I don't know, we need something to base the rest of our presentation around. So I just invented this class called PyYYC presentation. And I don't know if this is the best I could do with getting it visible. Good enough. But yeah, so in this PyYYC presentation, you have a presenter, and a topic, time limit, number of slides, and a slide color. Definitely have to have that number of slides, because as you can see, all presentations are done in PowerPoint. And then just like a few functions. So this is kind of the core of what we're working with. It's just, yeah, just a little class. And so when I say data, this is kind of what I'm talking about. Like, right now in this class, it's only what we really care about. Like, we really care about having a presentation, and we care about the things that are in this presentation. And, yeah, so this is pretty much solid, like, things we care about. We care about each of these components, and we care about all these functions. And there isn't much, like, code or logic going on in the background to make things confusing. So I wonder if does this get bigger? I do this. Yeah, that'll work. So we can start here, and we can make a presentation and give it sort of stuff that makes sense. The presenter is me, and the topic is meta classes, and a time limit, and slides, and slide color. And we can call some of these functions just to make sure they work. So summarize makes a nice summary. Time per slide, that does some math. Strains eyes, it calculates that from the slide color, the slide color you gave it, just some funny thing. Anyway, so that all works. But right now, it's really easy to break. Like, there's just, what's going on is really basic. So like, say someone comes in and is like, haha, I'm just gonna totally mess this up. It still runs fine, and the functions either work and don't really make sense, or they just break. So there's an error because you're trying to divide strings, and it's an error because you're trying to use a string as a color. And even if you're like a Python guy and you kind of know what you're doing, and you're like, all right, well, I'm gonna look at the documentation. Okay, so it's a presenter, topic, time limit, blah, blah, blah. You can still mess it up pretty easily. Like here, I put my time in as a string, 4 hours and 30 minutes. That sounds like a reasonable length of a presentation. And that works fine, but then it tries to do this math, and it fails. And this doesn't work either, because who knows what we used for color? White. White doesn't work as a color. Anyway, so let's start adding some logic. So this is the other part of what I'm talking about. Like, instead of data, which is what that previous thing was, we're now going to start injecting some logic. So I can scoot over here, I guess. So if you scroll down through this class, you can see the same stuff, but now you have all these goofy set presenter, set topic, set time limit methods. And so right now my expectation is, of the user of this program, is that they just use these set methods rather than actually just assigning variables. But in these methods we have some logic. So, for example, if your presenter isn't a string, then you get an error rather than it letting it just move on. So let's see this in action. So if you're using this in a well-behaved manner, it works fine. And then you can use these set methods that I made, set the number of slides, and you see, okay, the number of slides is 15. And then here, if you try to set the time limit to whatever, and it says, well, no, you can't do that because time limit must be a float. However, this is still exceptionally easy to break. If you just actually assign time limit to whatever, it works fine, and you're back where you started. So I mean, in addition to throwing errors, you can also do more interesting stuff in these setting functions. So like here, if we set the slide color to red, that was okay, it didn't get an error, and then it actually set the slide color to this RGB value. So if you scroll down here in this set slide color, you have some logic in here that's doing that setting. Cool. And then if you look at this previous thing, that now doesn't work, which is good, because they're assigning strings to floats. Cool. So on to the next step. So these set functions are not very Pythonic because in Python we have properties, so we can make all these different attributes into properties. So I don't know how many people have seen this. I think most. It's a pretty common thing if you've worked with Python much. So using this at property, this is a wrapper, so it wraps your functions, and then when you do that, it behaves just like you're setting it, like you're directly assigning it. So you can still set it in this way without actually using a function, but then it actually runs this logic when you set it. So we can run through and see how that's working. And with this, we start out here. So now we want to set the number of slides to 15. Okay, that works. And then we also have this underscore in slides. So if you go back and look at exactly how this is working, so now in slides is kind of a function, and when you get in slides, it just returns this underscore in slides. And then when you set in slides, it goes through this logic to make sure that what you're setting is okay, and then it sets the underscore in slides. So that's good. And now when you do this line, which worked fine before, you get the same error. So on this assignment, it's going through that same logic and saying that time length must be a float. And you can also have more complicated logic, like for example, just on that assignment there, you're actually turning color into an RGB value again.
All right. So now let's get into what we were talking about before, where we start separating out this logic. So if you look at what we just had, we're still in our presentation class, and all of these setters and getters are just taking up all sorts of lines of code, blah, 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 and then we have like the few things we care about are also in there. So I think for the first step, to separate out this logic, we're going to try class inheritance. That seems like it might be a good idea. So if you see what's in the box there, it says base presenter, or base presentation, I guess. So yeah, I define this class base presentation, and now this class contains all of this logic, all of the property getters and property setters. And then down here we have our PyYYC presentation, which is a bit more focused on just some of the data we care about. I mean, it's still not great because now we're missing a lot of the the property. What properties the presentation has, you have to go up and look and see what's in the base presentation, but we've at least kind of split it apart a little. So that's the first step of separating logic. And now the advantage with that is we can have this PyYYC presentation, and then we can also have like a YYC.js presentation, and they both can inherit the same logic from base presentation. But I mean, this quickly gets really messy. So now we have another presentation, this free spirit presentation, and they do away with topics, they do away with number of slides, they do away with everything. They just have a presenter, and they talk about their favorite color. So now, in here, we can still inherit base presentation. I guess I'll scoot over to the bigger version. So that's our PyYYC presentation, that's our JavaScript presentation. And here's this. So we can still inherit this base presentation, but since we now are using such different properties, we have to override the init function. And now instead of having slide color, which was our color before, we have favorite color. So we have to reintroduce this color logic. So now this is basically just copy and pasted from up here, the same logic. So it's acting on a different property, but it's the same logic, and that's not great. Cool, yeah. So you can go through and see that works if you want. I think that's not particularly necessary. So we can maybe try to solve this problem with more subclassing. So we can make it so all of our base presentations are they really only have microscopic changes between them. So now instead of just having one base presentation, we can have a really basic presentation that just has a presenter, and then we can have a normal presentation that has a presenter, a topic, time limit. We have and a PowerPoint presentation which has all that same stuff plus slides. And then we can go down and see our PyYYC presentation inherits this PowerPoint presentation, so does our JavaScript presentation. But then this other presentation now inherits the really basic presentation. So I don't know. It's kind of just creating a big mess of a bunch of different classes. And I think our goal really wasn't achieved because...
Do you have UML diagram?
No. We'll soon kind of be out of this mess. Because it's not achieving the goal that we had in the title of our talk at least, which was separating logic and data. So it separated some logic, but we can see that we still have all of this logic inside our class. So I'm going to say we're not really doing what we want right
Am I
now.
the only one who's not entirely sure why we're trying to achieve this goal? What is the intention?
Oh yeah, sure. Yeah, so the intent is because, well, you want to have a program that's, you might want to have a program that's easy to use, or a way to easily make changes in kind of a declarative way. One of the talks that Rowan had that we didn't watch talks about declarative, creating like a declarative interface, and that takes all of the stuff I'm calling data, what we care about. You can just declare it. You can say, okay, we have a presenter, a topic, and a time limit. And then all of the logic that happens underneath is somewhere totally separate. So if you're coming in and you're just like, okay, I don't really want to program too much, I just want to make something that works, then you can just do this really simple declarative thing. And then if you really care about algorithms, you can be like, well, I don't really care if this is a PyYYC presentation or a whatever other kind of class. You can just go and be like, oh, but I'm really interested in making the color property super robust and able to deal with any sort of color. So it's just kind of a separation of those things. Is that reasonable motivation? Cool. Yeah, so I think we kind of talked about this if you want. I put these in here so you can import and play with them if you want to see if they work or see if I have a typo, but I think it's not exceptionally important to play with our classes. So yeah, so this next step, we're actually going to try to remove the logic, these big chunks of validation logic out of our program. So if we go over here, so now at the top, we define these functions. So we have like a confirm color. So now this just does the validation. So if you go back and look here, then within this setter, so this is a setter of favorite color, you have all of this stuff happening. But now we've taken that out and just put it in this confirm color function. So then if you go back down into the code where you are actually using that, then within these setters, you now are just calling these functions here. So I think that's a bit better. So now, kind of as we were saying, if you want to change how you confirm a float, then you can just change it in this method up here rather than having to find everywhere that you have a float property. And then this is also, so this kind of shows how this is useful. So now we're just going through testing these functions. So we're going to test confirm color on red. Let's see. That's rough. Oh, yeah, because I made that one follow pep8. Look at that. Wonderful. Okay. So yeah, but then, oh, we found this problem. Like, that's not a color. That's 10,000.1.3. So now we want to fix that everywhere we're dealing with a color. Rather than having to find everywhere in the code where we're dealing with a color, we can just go into our confirm color and be like, oh, hey, why are these lines commented out? That's convenient and unnecessary. And so all we had to do was just add additional logic into this function here. So now this checks to make sure that our BG values are integers and make sure they're in the right range. And then if we restart our kernel, import this again, then we get an error here, and now our logic is a bit smarter. Yeah, so then if you wanna be Python-y again, it's pretty easy to, well, maybe not pretty easy, but somewhat straightforward to turn these functions that I wrote, these confirm color functions, into wrappers. So instead of, sorry that I'm switching back and forth. But yeah, so instead of having this like confirm string as a function here, you can instead use it as a wrapper. So that didn't really save you any keystrokes, but maybe it strokes your Python ego a little. And so really all this is doing is just, so a wrapper, it takes a function as an input, if you need a brief primer on wrappers. It takes a function as an input and then it returns a new function. So here we use confirm color, so we take the function that we want the value to be confirmed, and then we do this validation, and if the validation works, then we just return the function. Anyway, you can read more about wrappers. This is about all I'm going to talk about it, but this, I mean, it works the same way. If you were to run the validation works the same way that it's worked in all of the past ones. It's just a bit more abstracted. So that's that. Okay, but here I think things are maybe starting to get interesting. So if you look in our wrapper code, we've taken out a lot of the logic, but we still have all of this repetitive at property def something return self dot underscore something at something setter something def dot blah 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 blah, and then we have the same thing here at property def blah 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 at setter blah 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 at property blah 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 at setter blah. So so we've taken out like the logic that we care about, but we also have all of this code that we kind of want to take out too. So it would be really nice if we could just, if you can kind of see here, turn this big box into one line. So now this one line only has a few things. It has favorite color, color property, and underscore favorite color. And those three things are really the only three things that change between all of these property and setter blocks of code. So like here you have time limit, you have a confirm float, and then you have this underscore time limit. But property, self, def, return, setter, self, value, self, that is all like totally repeated. Whereas in, sorry, jumping around. Whereas here you have nothing repeated. You only have the I guess, the data. So right now you know, okay, in our normal presentation, we want a property called topic, and we want that to be a string property, and we want it kind of assigned to this underscore topic location. So this is really nice, but we have to figure out how to make this work, which starts to get a little bit complicated, but, well, maybe not starts to get a little bit complicated. Continues to increase our complexity, let's say that. So we need to get into Python descriptors. So in Python you can overwrite these get and set. Oh, hey. You can overwrite these get and set methods to make whatever you want. Rather than just getting a value, you can get whatever when you try to access that property. So here what we're doing is we have this special property, and when we try to get the special property, we actually return whatever is stored under this secret name. And then when we try to set this property, first it checks to make sure that what we're setting is okay. and then it sets the secret name to the value. So it doesn't actually directly set what you're trying to set. It sets something else. So for example, here, when you try to set topic, when you say like normal presentation dot topic equals meta classes, it actually sets underscore topic to meta classes. So I guess we should probably start executing code again to show how this works, at least a little bit. So this is just our same presentation from above. And now what we're doing here is we're setting a slide color. So then if we scoot around, we find where slide color is defined. So now slide color is this color prop. So when we set it, we're actually setting this underscore slide color. And then if you go up here to your color prop, zip, zip, zip. So now color prop is a special prop. So when you set color prop, you first confirm it, and then you set your underscore color prop. And it uses the same logic to confirm it as before. So let's see. So when we set this, okay. So now when we get it, so it went through the logic, but really the variable that's being changed is this underscore slide color. So if you look at that, that's the same thing. So when we say get slide color, well, when we access slide color, we don't actually say get, then it actually grabs this value from underscore slide color. So that's kind of tricky with what you're doing, but when we go back to our conversation before about making the program really understandable and easy to use, now whoever is writing this presentation class, they don't even have to know about at property wrappers, they just have to know about your about your property library, and they can say, well, topic is a string property, so I'm gonna write this in my code, and I don't really care what it's doing. Okay. Good. So let's take a moment. This next step just gets rid of our old subclass structure. So that's really nice, because now that we have these simple one-line property descriptors, then if we just go back to our PyYYC presentation, we're back to inheriting object. It just takes 5 lines to say everything here. And it's not that big a deal if you have a similar class to just repeat those 5 lines rather than having some complicated class inheritance structure. Yeah, so that's really the only change there. All right. So, I don't know. Moving on to the next thing, I guess this is a bit different, so you can step away from the previous changes we were making. So the next thing I don't like, if we look here, this is really nice. When I just look at this, I see, okay, well, we have a presenter that's a string, a topic that's a string, a time limit that's a float. But then the next thing you get into is this huge initialization thing, which is really kind of clunky, and it just repeats what you have here. Which, I mean, is fine, but it might not be what you want. Like maybe you have a property, or a class that has 1,000 different properties. It would be pretty crazy to have them all explicitly written out in the init function. So then to tackle that, we are going to just make our init function take in keyword arguments, which we've actually been doing this whole time. And so, get the right place. So if you ignore all this commented out stuff, then it just takes whatever arguments you give it and it sets them. Yeah. Which is fine. So now if we restart this, import this next version. So it now works the same as before. If you initialize everything at once, that's good. But you can also now make a new presentation where you don't have to initialize everything. because it's fine if you don't give it any keyword arguments. And then you can start to just add things as you go. So it's maybe easier to use, or I don't know. But so you can still set new pres.timeLimit. It still has all that validation that we were worrying about before. Cool. But now we get to the point where we maybe want to introduce more logic, because we are once again at a program that's pretty easy to break just by using it. So we take this new presentation, which we've only given a time limit, and we call our function summarize, which tells you about the presenter and the topic. And that, of course, doesn't work because PyYY has no attribute underscore presenter. So that, I mean, that makes sense. We didn't give that presentation a presenter. But this is also not a particularly useful error message. So it might be good to introduce some logic to get past that error. We also can maybe have bigger problems if we're not careful. So for example, we have this function summarize. Since this is Python, you can assign something else to summarize. And it lets you do that just because everything is an object. So a function is an object, and you can reassign the function to a string. And we can't really do anything about that. However, it's a bit of a bigger problem that we can do that when we're initializing the class. So here, when we're initializing PyYYC presentation, we could set summarize, since we're just taking keyword arguments. They can be anything. So we can set summarize to a string. And when we're doing this, we don't actually have any idea that summarize was supposed to be something else. So this is kind of a bigger oops, I guess. Like, I think it's okay that once you have your class and you see that summarize is a function and you are like, oh, I want to change that to a string, there's nothing you can do about that. But here, you don't even know that summarize is a function. And of course, that works just fine. You can also do kind of nefarious things, like if you set this underscore presenter and presenter, then who knows what happens. But it lets you do that. So yeah, so I think maybe we can introduce a bit more logic just to make things more complicated and give us more logic to remove. Introduce some logic to deal with all of these errors that we ran into. So let's deal with this error first. So here we're assigning an underscore thing. Well, since our underscore things are private properties, we don't really want people to assign those on initialization. So we can uncomment this line. Say, okay, if one of your keys starts with an underscore, then just don't let that be set. Something else to fix is when we try to access one of our properties that hasn't been initialized yet. So rather than getting a kind of cryptic error like this, we could go into our getter. So this is now in our special prop. Everything, all of our int props and string props and color props are all special props. And then we're going to uncomment this. So now, when we try to get that special prop, if this attribute doesn't exist yet, then we get a nice error that says the property hasn't been set. So we can see that in action in a minute. Let's actually see that in action now. Let's do that. So we're just going to start over with this new code that we just changed a little bit. We're going to make our new presentation. We're going to just give it a time limit, and then we're going to try to summarize. So now, when we try to summarize, we get this better error. It says presenter property not set. So that's just some additional, that's this additional logic that we put into the getter. And then when we try to do this here and set the private variable, then we get another error, cannot set private property underscore presenter. So that's good. So now this one is a bit more complicated to deal with. So for this one, I think the solution should be maybe when you're initializing these classes, you only allow your special properties to be set. So you can't set anything else. You can't say PyYYC presentation like venue equals assembly. You can't do that. I mean, you can now, but it would be nice if you could only assign your things that are defined as special props. So that would be, only define these 5 things on initialization. So now if we think about how to do that, okay, we're going to want to do that in the init function. And I think the first thing I'd try is this here. So we want to check if the keyword you're trying to set is a special prop, then just say it's not available. But when we try to access this special prop, we call the getter, and the getter is doing something funny. It's not actually returning the special prop, it's returning the underscore secret thing. So I think maybe when we do this, we might see a funny error that maybe will import again. So we're going down here, we're trying to set things that aren't properties. So what error does it give us? Property not available, summarize. Hey, that worked. Okay. Cool. Yeah. So that didn't let us do that, but now we have a different problem. So if we say topic equals meta classes, let's see what happens here. Did we also get an error? Yeah, we also got an error. So that shouldn't error, right? Because we're checking to make sure what we're trying to set is a special property, and topic is a special string property. But if we go down and look at the error we got, property not available topic. So why is that the case? So it's telling us that topic isn't a special prop, and if we think about our getter, when we get topic, we're actually getting the underscore topic. So when you say get, right here, when you're calling this, it actually doesn't return the string prop topic, it returns the underlying underscore topic that your getter told you to get. So that's funny and a bit unexpected, but makes some sense. So this is kind of starting to get into where meta classes are helpful, but we can still work our way around it if we uncomment these different lines. So let's do a couple different things. Let's check to make sure it has an attribute of the key. So here topic is definitely going to be an attribute. So topic will definitely pass that. And now we want to dig a little deeper. So instead of getting the keyword argument for that key, you're actually going into the class dictionary and seeing how the class dictionary defined topic. And so doing this kind of messy business, that then doesn't access your underscore topic, that actually accesses your real topic, and it sees that your real topic is an instance of special prop. And so then hopefully, if all goes as expected, if we go through this rigmarole again, now we should be able to assign topic, oh no, topic, property not set. Oh well. Anyway. Yeah, that's kind of the idea. As attribute. Yeah, I guess I'm not going to stress about it too much. But only a little. So where is this doing it? So this is actually going in here, has attribute self key. Oh, so I guess this has attribute self key is calling that. Let's see if we just get rid of this and we're smart.
What key are you pressing when running the code?
Oh, it's shift enter. Shift enter, yeah. It just becomes second nature, but it's totally unintuitive for months. Yeah.
Well, that's the thing. Keys are great, they're fast, but they're not visible to me.
Yeah. Yeah. So cool. So this just worked. So so the stuff I wrote here wasn't perfect, but what we were trying the problem that we first encountered that we were trying to get around, we managed to get around. So I'll say that's good enough. Anyway, so that's some trickery that I think we can maybe kind of move on to the next step, and just not worry too much about going forward. So we've now introduced all this new logic. Let's just pretend this works and leave it back in. So we've introduced this. This is now, like if I'm trying to decide what in my code is data that I want a user to be using versus logic that I want a really slick programmer to be using, this definitely looks like logic to me. And it's still in our presentation class, so let's just yank it out, and we can actually go back to our subclassing to do that. And so in our next version, we now have this with special props class. And so now this is designed to do this initialization function for anything that's using these special properties. And so now our data class inherits this with special props, but then it's back to just having really nice, clear, declarative data. So that's good. Yeah. I think we should probably just continue to delve even deeper, and even if you are lost, maybe you're enjoying seeing where things can go, and you can always Google everything. So now we're going to get into meta classes. So the first thing I'm going to do is just kind of show you how I use meta classes. Like if you Google meta classes, that's going to be a really big can of worms that I don't know. I Googled meta classes on like my first week of work, and then a couple months later had recovered and started using them in a kind of practical way. Yeah, so just some syntax things. This is all Python 2.3 compatible code. Oof. So we use this with meta class function, which is something we import with meta class, and then so now this with special props has this meta class secret name meta, which we defined up here, and that's fine. I mean, this is just syntax, which is not exceptionally important. And then, I mean, if you Google meta classes, they'll talk about how meta classes are like classes of classes, so they inherit type, or they're classes of types, I guess. I don't know. Anyway, meta classes, though, inherit type in the same way that classes inherit objects. And the only meta class function that I'm going to use is new. So I think there are a bunch of other of these special functions that you can get into if you want, but this new is reasonably straightforward with what it does. So it has a few different arguments. You have meta class, name, bases, attributes. So I'm just going to start by printing these, just to show you how this works. So if we scroll down to this, reset our kernel again. So this is just on import. It does this printing, which is pretty neat, I think. So yeah, this new runs when classes are defined, rather than when classes are instantiated. So it only runs once, and that's when you import the stuff, but then it runs and it builds all of your classes, and it runs this new function which then creates your class. And so you can look through what's in here. This is kind of a bit of a mess. But if you, so if you just start looking here, so this is printed out for our PyYYC presentation. So MCS, that's like self. It's like self in the meta class, so it's a meta class, but it's basically self. The name, that's the actual name of the class that's being created by the meta class. Next is bases. So the bases, that's just the classes that it inherits, so with special props. If you go, you see, our PyYYC presentation has with special props as a base. And then the attributes. So the attributes are everything that exists inside that class. So you have a doc string, you have some funny Python things, modules, but if you dig through here, you can also see, you have topic, and it knows topic is a string prop. You have, what else? You have like slide color, that's a color prop. You have these functions, you have your summarize function, you have your strains I function. So really what you have now within this meta class is a totally deconstructed version of your class that it is about to put together when it returns. But you can get in there and muck around, which lets you do really things that'll really frustrate people who are trying to use your code in the future, I guess. Yeah, so let's just start out with something really simple. Well, sorry, I think I keep saying that. Relative to where we are now. So right now, this is the next version of the code. So instead of just printing out meta class, name, bases, attributes, we're going to reassign name. So before, name was our class name. But in the meta class, we're going to say, no, we don't want that name. We want a new name, and then we want to make a class based on all of this stuff. So let's run this. Yeah, what I'm doing there is I'm pushing 0, 0, and that resets your kernel, which makes all of these imports not overlap, because everything I'm importing has the same name, so it'd be a big mess if I didn't do that. Yeah, so so we just imported that. Let's initialize our presentation. So the meta class was run on import, and then the class init was run just now when I did that, when I just initialized it. And now, if we look at this, well, the presentation.class.name, I mean, it's clearly a PyYYC presentation because we just did it the line before. But then when you print that, oh, no, we were thwarted by our evil meta class, which renamed our class totally arbitrarily. Yeah, so that is, that's kind of, I mean, that's like a really basic thing you can do, but that kind of shows how it works. Like, to someone running your program, they just run it like normal, but then it does all this funny stuff in the background. So let's, instead of doing this, because this is just nonsense, let's do this instead. So let's take a look at what this is doing. So we're first defining this underscore props as a list. Then we're going through all of our attributes. So if you remember all of our attributes, that's everything in the class. So that's the doc string, that's the functions, that's the different properties. And now we're checking if that attribute is an instance of special prop, which this line gave us some trouble before, because when we were accessing the attributes before, it was going through and getting the underlying, calling the getter and getting the underlying secret hidden thing rather than the special property. But since we're doing this just on a class level, before the class is initialized, it just sees those attributes as these special props. So anyway, I mean, I guess probably if I hadn't pointed that out, this would have just looked fine. So anyway, so this is fine. So now for everything in the list of attributes that's a special prop, we can add it to our list of underscore props. And then we just add that to our attributes here. So now we're saying this props that we defined in the meta class is now going to be an attribute of the class we're defining. And yeah, so then if we run this, even though in PyYYC presentation, there's no hint of anything that's underscore props, since we built it in the meta class, we see that, oh, our props are these guys. So that's pretty nice, I guess. I think it's nice. And we can use this now to simplify one of our messy steps. So we had this messy step here, which is so messy it didn't even work, to get around our getter that we messed with. We had to do this underscore class underscore dict to see that it was a special prop and not just a string. But now we have this underscore props that we built in the meta class, and so now we can just say, oh, well, if it's in there, then we can say that, or if it's not in there, then we say we can't set it. So this only allows us to set the things that get identified in our meta class. So I mean, this, I don't know, this kind of goes with the title of the topic, I suppose. Like, you're taking this bit of logic and now putting it in the meta class. Yeah, so let's see. Shall we just move on? Maybe we can B. If you do B when you're in the overview mode, it makes a cell below where you are. You have to hit escape to toggle between the actually writing code and the overview mode. And I also just zoomed in.
Double click with two fingers.
Cool. So let's see if this works. So what do I see? Presentation. So now we want to set topic to meta classes.
I actually got something for you.
Nice. Wonderful. So that allowed you to set it because topic was in this underscore props. And then if you do something like venue equals meta classes, not only does that not make sense, it also sees that venue is an unavailable property because venue did not appear in your underscore props. Cool, so what's next? All right, so now something else that I think we can only maybe do with meta classes. Well, I'm sure not only with meta classes, but meta classes makes it really easy. So we're now in our PyYYC presentation. We want this to just be data. And we're mostly there, but is it really data that we have presenter and then underscore presenter, topic and underscore topic, time limit, underscore time limit? It seems like that's a bit redundant and should be unnecessary. However, like when you initialize the string prop, it doesn't have any idea what you're assigning it to. So when you're actually just running this line here, there's not really any way for the string prop to know, oh, well, I'm being assigned to presenter, so I'll make this underscore presenter variable. However, the meta class, since it's just like takes a step back and just looks at the class as it's written, it does see, oh, okay, well, this presenter is setting a string prop, and it knows that, or this presenter is being set as a string prop. And so the meta class knows both the variable name, presenter, and the property, string prop. And so it can say, oh, well, I'm building this class, let's just make this underscore presenter and pass that in ourselves rather than making the user do it. So if we go just to seeing how this is working, oh, okay, so now this is now what we have in PyYYC presentation. So this is the end goal. We want this to work in the same way that it was working before. So we still want presenter to actually be assigned to underscore presenter. But that's all hidden away. So how can we maybe go about doing this? So we have to look at what we changed. So we've now made it so there's no input variables. So this was our old init function. it took in the secret name and assigned a secret name. But now our new special prop, we don't want to give it the secret name. We just want secret name to exist as it is. So secret name here is never being assigned, at least within the PyYYC presentation or the special prop. But if we now sneak down to our meta class, then we have the same loop where we were building our underscore props. So we can also take a look and say, oh, well, for all of these special props, we want to also assign secret name. Instead of the none that it was given before, we want to assign it this underscore key. And so the key goes back to the attributes. So the key is just the name of that attribute. And so then these special props now know about these underscore secret names without it being explicitly written out by the user. So that's kind of what this goes through with some nice sketchy X's, and let's just maybe take a look to see how this works. So import that. So now we're just making our presentation again, and this is using this code here, where it doesn't look like we do anything with underscore anything, but when we look at underscore slide color, oh, it's set as our slide color. And then, I mean, this is all, has the exact same functionality it had before, but it's just slightly easier for the user writing the code. So here we assign our slide color as red, it goes through, it performs that logic, sets slide color, and what it's actually doing is setting underscore slide color. Yeah, so this is just getting more and more complicated, but we're achieving our goal of separating data and logic, I think. Something else interesting we can do in meta classes. So if you think about this for a minute, say that we have a key named props. We're setting this secret name to underscore props, then that'll conflict with this other underscore props. So maybe we want to catch that. So this, yeah, so we write a little bit of code to catch that. Here we go. So if you have a special prop that the key is props, you say, oh, that's not okay. You can't have a special prop named props. And now this validation, it's in the meta class. So it gets run when it gets run on import, on the class definitions. So before you even start working, it tells you, oh no, you did a bad job writing your class. We're not okay with that, so change something. So I have another super duper hip example just to show this in action. So right now I'm going to define this class, Skatepark Accolades. Yeah. So it has nothing to do with our PyYYC presentation, but it still uses our special props. And so we have a couple things. We have mad props, and then when you want to compliment something, you say, dude, props. I mean, seriously, mad props. And you're like, oh, why didn't that work? Can't have a special prop named props. I didn't even think about that. I was too stuck in skateboard land. So I don't know. I think that's kind of really nice, because now you've made this ability to create classes in a declarative way, and you've passed that off to the user to be like, oh, I've made this really easy for you. All you have to do is say topic string prop, presenter string prop, and then they say, oh, that's great, I'm going to go make my own thing. And then you can include this validation within your logic separately to be like, oh, actually, you constructed something wrong when you were making your class. So this is kind of a really nice way to have additional validation. So another thing meta classes are useful for, that we use all the time at 3-Point, is for auto documentation. So our PyYYC presentation is quite lean, but oh, there's still this repetition. We have this nice doc string that I wrote and copied and pasted 14 times. And then we're also repeating this here. But this is a bit repetitive, so I mean it's good because you have documentation and you also have your actual code. You don't want to lose that. Like in the end, you still want to have documentation and your code doing the work. But if we could kind of separate these or combine them, I guess, it might be nice. Yeah, so I mean, if you go back to the data and logic kind of thing, like this is your data maybe, and then your logic, I guess in a weird way, could be writing your doc string, and that logic is a bit of a tedious thing that you don't want to do yourself. So let's see what we can do about it. So the end goal is to have something that looks like this. So we have just our sort of general documentation, but then for each property, we can maybe give a bit more explanation if we want, in case just knowing that presenter's a string isn't good enough. So now this kind of encapsulates both the property initialization and the documentation when you're looking at the code. But then how can we make this so it actually generates real documentation? Yeah. Cool. Well, let's first go to our special props because we're now giving our special props something. So in special props, we now have to take in this doc in Init Function. It's pretty straightforward. And now, of course, we're going to go to our meta class to take what was once good and make it absolutely difficult, but also nice. So now this is what we've added here. The other stuff is still the same. So now we're trying to build our documentation just from the code. So we first can take the doc string that we defined. So this underscore underscore doc underscore underscore is like this stuff. That's automatically assigned to that variable. Then we can also go through our properties in underscore props, which we've already created up here. And then we can add a bit of documentation. So we want to say maybe the prop name. So prop is the name of the prop. And then we want to add this doc string, which is the property.doc, which is what we are defining here. So I think that this is not doing too much fancy. I guess this check is just in case you didn't define any doc string here. So really, this is all that matters. So you have your initial doc string, and then you also have one line of documentation for each new property. So let's see this working. So let's import this. Something else nice, I think it's an IPython thing, not a Jupyter notebook, is you can get doc strings with question marks. So PyYYC presentation, let's first look at what we're dealing with again. So it looks like this is all there is to our doc string. However, on our initialization, we ran through the meta class, and now when we generate our doc string, we get this useful thing that has both what we wrote out explicitly and a nice one-line description of each of our properties. So that's really nice. And this is actually something that we use to generate our online documentation at 3 point. I can just jump over here. So I mean, this is kind of the basic idea. Like all of this documentation is auto-generated from the code. It goes into this class here, which is just a volume. This is the string that we write explicitly, and then it goes through and it just sets all of this automatically in the meta class based on the properties that we defined. Cool. All right. We're getting there. We're getting there. So the next thing we're going to do, yeah. So another useful thing about meta classes, another thing we use at least, is you can, since it runs at the beginning, it kind of looks at all your code, and you can use it to kind of take an inventory of what you have. Well, this is just what we're doing specifically. We're making a registry, and then we're going through, and everything that goes through this meta class, so this is all the same just down to here. So every class that's created using this meta class is added to that registry. And so now we have knowledge about kind of like the state of someone's workspace almost. And like even if someone else writes their own module that has classes that inherit your meta class, as soon as they're imported, they'll appear on this registry, and so you can go through and take a look at them. So you'll, I don't know, one use for that, it's not exceptionally apparent to me how to use that in a good example, but one little example is, goes back to this documentation stuff. So first we do this. Let's take a look at our registry. So we just ran that code that was now registering all of the classes that were built with this meta class, which was our with special props, that has this meta class, and then everything that inherits with special props has that meta class too. So we have our PyYYC presentation, we have these presentations again, and so all of these will get registered on import. So now if we take a look at our registry, oh, there we go. So now it has just a list of all of our classes that use this meta class. And say we want to just generate all the documentation for what we're working on right now, we can just loop through this registry and then generate those docs. And now we have this really easily generated documentation about everything that's currently being used. So that seems pretty okay. Yeah. So I realize that this is sort of just a huge mess and gone through way too fast to get any sort of real depth on, but I think it's maybe nice just to kind of give you an idea of the sorts of things you can do. And then now if we look at our end product, so maybe we can just deal with these side-by-side comparisons. So on the left, this was what we ended up with for our data class. So we now have all sorts of logic going on elsewhere. But this is now really super duper clean. It has just some documentation, it has your properties, and then it has what you do with them. And then if we compare that to what we started out with, so this is like version 0.0, as a matter of fact, what we have now is shorter. I think it's at least equally as like readable, and it's way more functional because it has all of that logic and validation behind it. And then if we compare it to one other thing, so now this is again on the left what we have now. If we compare it to a class that does include a lot of the logic, we kind of see what we're getting into and see like this on the right is kind of just a huge bit of a mess that's kind of hard to dive into, whereas on the left this is nice and useful, I think. Yeah, so Rowan mentioned that this was kind of like our properties class that we use at 3-point science. So what I've built is basically a lightweight version of properties. So if you compare over here, this is what we built today. This is our with special props, and we have like string prop, float prop. Whereas over here, we're actually using our properties class. So we have this same class we have the same class, or a similar class, property class, and then we have like properties.string. But the basic idea is the same. It is, of course, more powerful because it was written in more than a few days. And I guess I can scroll through this over here. So this is just an example of how this declarative programming is nice and is nice to use. Okay, so now we're just importing properties. So all of our logic is happening in properties. It's totally gone. We just import all that logic. And now here we have a string property, float, int, color. That's what we had before. But maybe we want to get more clever. So the properties class also allows us to have pointers to other property classes as properties, which sounds maybe confusing, but really all we're saying is that, oh, okay, well, presenter really isn't a string. Presenter is a person. So let's make presenter a property that's a pointer to a person. okay, this is all like everything we say here is useful. Like this is data. Presenter is a pointer to a person. It's required. Like that's very declarative. You're not saying what it means that it's required. You're just saying that presenter is required, a required component of this presentation, because you won't have a presentation if you don't have a presenter. And then you can maybe say the topic is a string, and so all of these things like required and default, they're just more things that are going on in the parent classes and the meta classes to make this declarative, logic-free, easy-to-use class building. So yeah, one thing we allow is default, so we can say, oh, the default topic is Python, default time limit's 90 minutes. Maybe instead of having number of slides and slide color, we can actually make slides be a pointer to slides, and we can have it be repeated. So it's like a list of slides. And now we say, oh, okay, well, we've never defined this person and we've never defined this slide, but maybe we can do that in like 5 minutes. Okay, so a person, what does a person have? A person has a name, which is a string, that's required. Everyone has to have a name. And a bio, okay, but it's not required. Also a string. And a slide, all right, what do I want a slide to be? Just topic, which is a string, and we give it a color, which is that. And so this was really easy to write, and I think anyone looking at this is going to be like, oh, I understand exactly what this does and what you're building, even though they don't really know how a lot of this is implemented and where the logic is that sets the default. All of that is just totally gone. Cool. So that is the end of my versioned codes. Oh, here, this also works too. So it wasn't just bogus. So like, if I do this, I can say me. I'm a person. My name's Franklin. I have a super spiffy bio. Make some slides. Make our presentation, and then we define this function cliff notes. That's just a new thing we defined. Yeah, I don't know. It prints our summary, and then it also prints summaries of all the slides. So we can do that. Boom, a nice summary of that. Yeah, so I think that's reasonably nice. I don't know. Sorry if that was too much of a whirlwind, but it's all online. And yeah, you can, properties is on pip, so you can pip install properties and start to use it, and the source code is on GitHub, and it's documented, and yeah, and you can also check out our other product, Steno 3D, which Rowan showed you briefly.